To finish this lesson, we'll move to something completely different. Early in the lesson, at the beginning, we discussed the way to develop the law of sines, actually by using an altitude within a non-right triangle. Well, if you noticed, that altitude, the height of the triangle, could actually be written as a trigonometric statement, basically. And so we can actually use this when trying to find the area of a triangle. So if you run across an area of a triangle problem, you may recall that the area of a triangle is just 1/2 base times height. Well, if you are dealing with a triangle that you do not have the base for, but you are given certain angles within the triangle, then you can actually come up with a trigonometric expression for the height and use that to help you solve a triangle's area problem. So depending on what parts are given to you, if you're given a base and you're not given the height, if you're given the height, you're not given the base, there's many different ways that we can work our way in backwards to those given parts and then use them to find the area of a triangle. Now, depending on which parts are given to you will depend on which altitude you need to draw. So your altitude may come from point C, it may come from point A, or it may come from point B. So you need to pay very close attention to that. Now, in this particular problem, or this particular formula, we've actually let K represent the area of the triangle. So I don't want you to get confused. I know in geometry you use the capital letter A for the area, but we use the capital letter K here so that you don't confuse the capital letter A with a given angle A. So we'll use capital K for the area. So if you see these three possible formulas depending on where you draw the altitude, you can use that to actually solve the problem. So go ahead and try sample problem 5 with the given information. Okay, so what I've done here to kind of just give you a little insight is I've given you, I've drawn an actual triangle here with the given information. We have a side, an included angle, and a side. And we're asked to find the area. So here we have a base of 12, but we don't have a height. So if I drop an altitude to represent a height, I can represent this height in this right triangle, and I can say that the sine of 52 degrees equals the height over the hypotenuse, the opposite over the hypotenuse. And so 8 times the sine of 52 is what's going to represent the height. Now, I know I have a base of 12, and I know that the area is going to equal to 1/2 times the base times the height, which in this case is 8 times the sine of 52. And so that's basically how we can come up with our area formula using trigonometric functions. So all I need to do is actually just punch this straight into my calculator, and I get an area for this triangle of 37.8. Now, in this particular triangle, I did not give you a unit of measure, and we should know that an area is units squared, whatever unit measure is. So I can just write units squared, or you may even use units squared, whichever way you want to do that. So that is our final answer for this particular problem.